The GIM Channel podcast, bringing you the big picture on geoscientific information management through interviews and discussions.
Hello, welcome to Acquire's podcast, the GIM Channel. We're here to deliver insights on people, process, and technology for one of the natural resources industry's greatest business assets, its geoscientific data. I'm the host of the GIM Channel, Sarah Mitchell, and I'm joined today by Misha Stacker from Acquire. We also have a really special guest, Bill Withers, one of the original co-founders of Acquire. 2016 marks 20 years in business for us, so we're excited to have him on board. Bill is now the managing director of Adapt by Design, which aims to help startups and established businesses design and build themselves into long-term, sustainable organizations with healthy cultures and values. We're chatting to Bill today to find out why he started Acquire back in 1996, why geoscientific information management, or GIM for short, is so important for the resources industry to manage effectively. So Bill, I guess the first thing that we want to know is, how did you come up with this idea to start building software to manage drill hole data?
We from about 1988, we were doing a lot of consulting work to help people store their drilling data. And it began with us doing work for Chevron, and I think that was 1988, and for Robe River at about the same time. They had a major issue that they were doing a lot of drilling and they had no place to store it. The general main planning systems at the time were very good at processing drilling data, but they were very poor at providing a means of storing the original observations and measurements. So from 1988 to about 1995, we set about building those systems on a bespoke basis, and we discovered that everything was lining up for us to be able to store drilling data in a generic form that could be used by any company that was going to store drilling data. And so the things that were lining up were hardware. So we saw that because of Moore's law, we were getting CPUs that were just going to deliver. There was the relational database manufacturers like Oracle, Microsoft, were starting to build products that we could see that were going to deliver. So it was the alignment or the confluence of three things. One is that we didn't want to build bespoke systems and we wanted to build a generic product. Two, we could see that hardware was coming to the fore that was going to be able to allow us to do it. Three, the relational database. Oh, and the fourth thing was we discovered a lot about third normal form and realized that if we separated the way people wanted to see data from the way people stored data, we could be far, far smarter and actually deliver on the generic solution.
Excellent. You just raised a really interesting point. We had Paul Murtaugh from Anglo American on in the last episode, and he reminded us in 1996 there wasn't even really the internet, or the internet used in commercially, across business. So thinking back to that time, what were the biggest issues in the mining industry in 1996? Well,
in many ways, the mining industry was actually quite well organized. It had leadership. A lot of the people that were senior geologists, senior engineers, they were very good at their craft. And when we would go out to do work at these mines, they were the ones that guided us. So we had solutions, but we get a lot of advice from them. The challenges were, though, that we had this incredibly complex problem where we were requiring very high amounts of or significant CPU, significant RAM, and we needed high-end machines. So for instance, in 1988, we bought the first microvacs in Western Australia, and we we were always seeking to find that machine that was going to give us the processing and the grunt to be able to deliver. So we would buy the leading edge workstations from Sun, leading edge workstations from Silicon Graphics. So the challenge was nearly always finding the machinery and the software that could actually deliver on the processing we needed to do. So one of the challenges for Acquire's foundation was we were trying to store data in this sort of atomic form, we called third normal, and then reconstitute the data on demand. And unfortunately, that reconstituting of the data took an enormous amount of RAM and CPU. And hence, I remember queries that today would take points of, would take microseconds, would take, could take up to 16 to 20 minutes. So, of course, it was totally, when we first built Acquire, it was totally useless because nobody could use it because of the processing time. But as Scott McNally, who was the CEO of Sun, said, build your software for tomorrow's hardware. And that's what we did.
Excellent. It's really interesting that you focused on data. Your background is geology. You're a geologist? No. In actual fact, before I went to university, I worked for 3 years as a geological draftsman, and as such, I learned a lot about the exploration industry. Then they gave me a cadetship and said, "Well, what do you want to do?" And I did a surveying and mapping degree. But in my first year of surveying and mapping, I discovered Fortran, and then I asked them if I could pivot to becoming a software engineer. So I ended up doing most of my courses in computer science and mathematics, and graduated to work with Charlie Bass as a technical software engineer. Okay, I got it. So if we look at mining, where we're always trying to find the commodity, which if it's gold or coal or whatever it is, that's a very tangible thing. But to a lot of people in the mining industry, data can be quite an intangible thing. So do you think companies understand how important data is to the entire asset chain?
Well, it's my experience that especially in the 90s, that they didn't at all. So our life from 1984 up until 96, we did a lot of resource modelling. And it was in doing that resource modelling for people that we realised that they didn't understand that their fundamental observations and measurements that were then going to be interpolated and in some situations extrapolated to actually define a model were actually fundamentally flawed. So they could be flawed, even the location, the coordinate data could be flawed, the analytical data could be flawed, the geology could be flawed. And so everything, the custodianship of that observation and measurement from the point of collection to its use in a modelling system was often totally flawed, and there was no auditing systems. So it was really crazy to me. I used to say something that was a little bit controversial at the time, but I would say if the mining industry ran the banking industry, you would go and put your card in the ATM and you would ask for $500 and it would either give you $5 or $500,000 and say, near enough. And I thought, I was having a crack at ourselves, but the point was that we didn't fully understand the importance of the original observations and measurements to all financial and safety decisions that were being made subsequently.
So do you think since that time when, that span of $500,000 was more or less, in your example, close, have you noticed a change then? Do you think that the modern miners are understanding why data is important?
I think it's been an evolution, and I think that we are still evolving. I think in the last 2 years, I haven't had as much to do with the mining industry because of my new direction. But what I observed is that the mining industry has evolved significantly to understand this, and now the domain, I think, of GIM is recognised and people understand the need to do it. I still feel, however, that if you think about the total expenditure on the mining value chain technologies that deliver the revenue for mining companies, I don't think that the expenditure seems commensurate with perhaps what they would spend on a maintenance system or maybe let's say an ERP. So they may spend orders of magnitude more on something that's managing the supply chain, and I could never quite understand that. So the thing that is going to deliver them the revenue is not getting the right level of investment.
Okay, well, let's talk about that for a minute, because the mining and exploration industry is notorious for this boom and bust cycle. And we're just in Western Australia, and I think in many parts of the world, we're coming out of the end of a bust cycle. So for a mining services company like Acquire to weather 20 years, that's a sign of resilience. What is your secret to building a sustainable company?
I think the leaders of a business, if they can actually design their business from boom to boom and bust to bust, and know that they are in that type of business, then they can actually design the strategies on that basis. So, for instance, the best one I can share is our attitude to people. So we're in the knowledge industry. We live and breathe, and our success is entirely underpinned by our people. So how do you attract and look after people for very long periods of time that can actually sustain through boom, or boom, bust, boom, whatever that cycle is? And so this means really getting smart about how you employ people and remunerate them and think about these things. Because if you set up your costs on the basis of a boom, it means that in a recession, there's only one thing you can do, and that is to reduce your costs by asking people to leave. So we consciously said, well, we don't want to do that. So there was two reasons. One is, I'm fundamentally a humanitarian and I don't want to ask people to do that. But the second thing is quite a pragmatic thing, that if knowledge was on the balance sheet, you would actually be hammering your balance sheet every recession, because you're actually asking all of your intelligent people to go and you're losing all of that knowledge. So whether you look at it from a pragmatic financial analysis perspective, or you look at it from a humanitarian perspective, it makes no sense. So my recommendations to people in the resources industry is always to say, how can we build our businesses where we design knowing that we're going to have rapid growth and rapid collapse, and just accept that and then design for it.
So then how important do you think it is to have a long-term commitment, the focus on a long-term commitment, rather than the focus we see a lot is on the short-term wins for the mining industry?
Yeah, well, I believe that mining, if you look at a lot of the resources around the world, a lot of the mining operations, they're actually designed for 20, 30, 40-year life. So if you're designing for, if that's the life of mine, we should really be starting to think as strategists along those lines. But it seems that there's a bit of competition that goes on between the financial industry and the quarterly returns and those sorts of concepts and delivering on that life of mine. So it's a real challenge, I think, in today's economic world, for people to actually say, well, I'm going to design a business that's going to be very good in the 3rd, 6th and 9th year, when people can often say, but I want it to be very good in the next 6 months. And so it's integrating both that short, medium and long term into the strategy of the business. And I think it's the holy grail, I think. But I think it's it's a very challenging thing for a lot of leaders to do this in the current economic situation.
So then how do you think GIM can help organizations prosper in these kind of market conditions that we've been experiencing in the last couple of years?
Well, I think it's GIM, but it's the integration with it's the integration along the mining value chain of GIM into the other systems. See, I believe that if we look at the revenue side of the mining industry, not only the minimization of cost, because what I've often thought about is if we have observations and measurements that are fundamentally flawed, what is the impact on the business when it comes to their subsequent mining? So what's the if as a leader my job is to mitigate risk, what is my risk if I haven't done everything I can to maximize the probability that I have a very good understanding of my mining resource? So I guess to sort of wrap all that up, I'm basically saying that if we need as business leaders to be able to define as clearly as we possibly can something that is very abstract like a mining resource, and we need to be able to do that as well as we can to mitigate risk. And I guess what I saw in 20 years of doing this is that we would have lots of situations where, because we didn't put that due diligence in place, many of those resources were not mined effectively, or they had very poor outcomes because they didn't put that technical due diligence in place and didn't really think about the full integration of that observation and measurement that was captured in the drilling phase, and what the impact would be ultimately on its extraction and on its milling, and ultimately on which affects both the financial success and also affects, if it's geotechnical data, safety.
Bill, you talk a lot about technologies, and you've got a technical background in software, and I guess working in the industry for the last 20 years, you've probably seen a lot of innovations and different technologies coming through. What are you seeing emerge today that you think's exciting for the mining industry?
Well, I might answer this a bit of a different way. Instead of saying what's exciting and emerging, because a lot of people might talk about automation or driverless trucks or, there's a lot of tech, but I don't know if that's really what I would think is the great challenge for the mining industry. I think a lot of this talk has been about saying, how can we get strategic leadership in the mining industry? Well, one of the things that I've observed in the mine sites I went to over the years, and I've never really seen the leaders take the bull by the horns here and really try and take on this challenge. I think that there's a great opportunity for new organisational architectures that actually break up traditional mining architectures. So, for instance, historically we used to have the geologists do the resource, then they hand over to a planning engineer, who they hand over to a drill and blast engineer, then they blow it up, and then it goes to the mill. And what tended to happen is that the organisation would be done by professional fiefdom. So they actually, by design, ended up with cultural and leadership challenges. So my belief is that if the mining industry could actually really go and challenge the way they design their mines, the way they look at the organisational architecture, and then really try and integrate their teams and get higher levels of collaboration, I think that's a place where there could be a lot of, and also really start saying, well, is it feasible for us to hang on to our people so that when the boom comes, we take a more measured approach to what salary system we're going to put in place, how we're going to remunerate people, how we're going to build that operation so that they don't have to have the negative event on the downturn. Now, there's many people who will challenge me on that, and they'll say, oh, well, it's just market forces and you've got to play market forces. Well, that's the part I would debate. I don't think you have to. That's a leadership decision. And so that's the great, I think that's the area. It's about leadership, culture, and how they integrate, how they build their companies in service of all of their stakeholders, not on any specific stakeholder bias.
That's great, Bill, and I think we'll leave it there for now. And I think you've probably made a lot of mining professionals really optimistic and hopeful with that kind of viewpoint on an industry that we don't hear those kinds of thoughts very often. So that's it for today. If you've enjoyed our discussion, please tell your friends and colleagues about this podcast, and you can find it on the Acquire newsroom at acquire.com.au. Thank you, Bill.
Thank you.
Thank you, Misha.
Thank you.
You've been listening to Acquire's podcast, The GIM Channel. Find us at acquire.com.au.